Yes, class. So we had started with moving charges and magnetism in the last class. So magnetic field we had started, we had discussed magnetic field, and then we had jumped to what was Biot-Savart's law. So basically, Biot-Savart's law said that the magnetic field is directly proportional to three things: current, current element, and sine of the angle which is present. And it is inversely proportional to the radius, which is the radius vector, right? So, final formula that we have here after removing every proportionality sign and all, it is mu naught ideal sine theta divided by 4 pi r square. Now, mu naught by 4 pi, this is equal to 10 to the power minus 7. So, that is the value of the constant which we'll be putting. Now, right hand thumb rule, which was right hand thumb rule we were discussing in the last class. So, in this example, current is upwards. If I curl my finger at a point, see, if I curl my finger, it is coming outwards. Outwards, how? It is away from the screen, right? It is away from the laptop. It is towards me. So, it is outwards. Look here. At B point, the curl is inwards, right? If I put my thumb along the direction of current and if I curl it, so finger at B point is going inwards. How in? Into the page. For A point or B point, right? And one more question we had seen, this example. See, again, this is the same: A point outwards, B point inwards. Now, second part, thumb downwards because current is moving downwards. So, thumb is moving downwards. Yes, thumb downwards, A point inwards. Right? This is inwards at A point. And see, at B point, outwards, away. Right? This is what we have discussed. Tell me, any doubts, anything that you want me to repeat? Tell me, take a minute, revise it. Then I'll start with method.
Ma'am, could you explain the second one again, where the current is moving
This
downwards?
one?
Yes, ma'am.
See, current is going downwards. We put our thumb along the direction of current. So current here is downwards. This is the direction of current. Look at my hand. This is my right hand. So this is the direction of current. Yes. Now see, at A point, this is A point. So here, when I curl my fingers, fingers are going inwards into the screen, into the laptop, into the page. So it is inwards. Fine. And when I have this, and at B point, when I have to calculate it at B point, look, B point is here. So it is outwards. Outwards. Fine. Now clear, yeah?
Yes, ma'am.
Okay, method 2 also let us discuss. See, in this, what we do, we put our all the fingers along the direction of it, and this is the method which I prefer. See, you can use any method. Both the methods are preferable. You can use any of these methods. Like A part, I'll show you. You have to put all your fingers towards the direction of current. Like this is the direction of current right now in the first example. And then curl the finger towards the point. Suppose I'm calculating A point. So A point is above. I'll curl. Okay. I will curl it. Where is thumb? Thumb is outwards. So direction of magnetic field is outwards. I'm repeating for A point. Put your fingers along the direction of current. Current is rightwards. Point is above. Curl the fingers above. Where is thumb? Pointing outwards. Now write it down. Tell me for all these 3 points. All these 4 points actually. Yes, so only Yaya has answered right. See, in example B, when we are calculating, we'll only use our right hand. So see, this is the direction of current. Now, I will not put my hand like this time. Because my point is now below, so I cannot curl it like this, right? So automatically I'll put my hand like this. So here thumb is going inwards, right? So here the direction is this. I've already told you about cross and this dot. So this is inwards. Now come to the second example. Hand, I will put my right hand like this, right? This is the placement of right hand. Now A point is above. So this cannot be curled, right? So I'll put my hand directly like this. A point is above. Now when I'll curl, finger is going inwards. And similarly for B point, thumb is going outwards. So here A is inwards and B is outwards. So any of these you can use, whichever method you are comfortable. I prefer the second method personally because I find it convenient to use using this. You can use that thumb also, thumb and curling of finger, or you can use this palm pen. Okay, write it. So we have discussed cross product earlier also, and now just little revision of cross product. So basically cross product is A cross B, two vectors. Now this is the polar form one, that AB sine theta we write A vector multiplied to B vector and multiplied to the sine of. Then for Cartesian form, we use this I cap, J cap, K cap. We go clockwise, and whichever third one is left, that we write like I cross J. So which one is left? K cap we write. J cross K, so I cap we write. Like this we move. Now for the signs, what we do, if we are moving clockwise from I to J to K, we use positive sign. If we are moving anti-clockwise from I cap to K cap to J cap, we use negative sign. That's it. So why is there a revision? Because see, we can use our Biot-Savart's modification also. This question, I'll come to this question first. Small derivation sort of thing which comes. See, current is I is equal to dq over dt. Suppose you want the current to come. All right, you want the current to come in your answers, or not even the current, you want the charge to come. So what we do, we have dB is equal to mu naught by 4 pi. Now I, instead of I, we can use it as dq over dt. I dl sine theta. So I dl sine theta. Understood? Instead of I have written this by r square. Now class, just one thing. Can anyone tell me this? What is dl over dt? Anyone? dl over dt. Distance over time, length over time. You are in class 12th. You must have done these topics already in class 11th. So yes, answer. I'll not move forward till you answer. Yes, Yaya, what's your answer?
Torque,
Hmm?
torque, torque,
Torque. Any other answer?
V,
Yes, ma'am. Torque.
Yes, Zaina?
Torque.
Torque. Since when class is torque dl over dt?
Velocity.
Velocity. Very good, Mariam. It's velocity, obviously. Length is changing with respect to time. Should I always directly write this? Dx over dt. Then only you are going to understand. If modification comes in your exam, board exam, how will you manage? Torque is always R cross F multiplied. All right. So this is the velocity over here. So I'll be replacing this with the velocity. Right. So this becomes C. Now dB, this is equal to mu naught by 4 pi. dq is here. And now we have V sine theta by r square. And let's do one thing. Let's multiply and divide it by r. So what are we left with? C class. We are left with dB is actually equal to mu naught, right? dq and dq v sine theta means charge into velocity sine theta. It's actually the cross product of this dq and v. Understood? It's actually the cross product of these two. Why? Because see, ab sine theta, it is following the same thing, right? So this is dqv, this portion. R is present, so R vector I'll write divided by 4 pi is here. This becomes R cube. All right, this becomes R cube. Then write it down, class, first, and then practice this question. This is a very important question. It's a very easy question though, but since it's in your NCERT books, it has been repeated. All right, first write down this. Make a note point and then start copying. And any doubts, please let me. And class here in magnetism especially, कोई भी answer बिना direction के नहीं छोड़ेगा. You have to mention the directions. Your answers are incomplete without the direction. Why? Because you cannot simply write towards right and left, right? You have to properly solve an intent. Write it. Yes, class, did you try this? I have given sufficient time. See, look here, class. When we are talking about this question, it's an important question and it's a very easy question. See, what's our formula? We know that magnetic field is mu naught by 4 pi ideal sine theta by r square, right? Now, mu naught by 4 pi is our constant, right? Which is 10 into 10 to the power minus 7. Current is already given as 10 ampere, so 10 dl. The length is already mentioned, right? This current element, it's mentioned in the question, 10 to the power minus 3, yeah. So 10 to the power minus 3. Sine 90 degree. So class, it is already 1 sine 90 degree. It's mentioned in the question. This question, at least, I was expecting answers from you all. And what's the separation radius vector? It's 10. So once you square it, it's actually 10 into 10. 10 gets cancelled. 10 to the power minus 11. And see now regarding the direction. Current is towards the x-axis. Point P is here. So curling my finger towards the point P, thumb is outwards. Outwards means which axis? Z axis. So K cap Tesla. This is how you have to write it. Right? Then now we'll start with the derivations. I've received some of your syllabus. Zaina, Khadija, Rishita also. Zaina, Khadija ka to hai. I'll just check once. Everybody please send your syllabus. Okay, that will help me decide with the classes and everything. Because September and October mein to sabke exams honge. So accordingly, we'll prepare. See, we need a major time for this chapter only. After this chapter, all the chapters are very small and they'll be done quickly. So do not worry about it. At least EMI is also very short. Write it, that we'll discuss later. But please send your syllabus with the date. Yes, class. One thing, application of bio. So that completes with the Biot-Savart's law. Now we have applications of it. Like in Gauss theorem, some questions were based completely on Gauss theorem, right? Then we had seen the applications of Gauss theorem, straight wire, infinite plane sheets, spheres, right? Now, here also Biot-Savart's law is over. Practice questions on that. Now we'll be talking about applications because application-based questions and mixed questions are present. So, see, magnetic field due to straight wire, you have a finite wire. Finite wire means ends are finite, like this is a finite wire. Another one is infinite, obviously. Means ends are endless, extending to infinite. This is not there in your syllabus. You don't have to do. Students who are preparing for their entrances after your this class 12 JEE NEET, you have to do this definitely. But those students who are just focusing on their CBSE exams and board exams, do not worry about that. Focus on this infinite one. Okay. Now, magnetic field due to circular coil, you have a complete circle, then you have semicircular arc, and lastly, you have just an arc. This an arc means any angle. So these are the things which we have to complete, not the finite wire. We'll straight away start with infinite. एक और चीज है, you have semi-infinite. That is also there. Semi-infinite is also. Write it. Then I'll start with this infinite wire. So yes, class, let's start with the first one. So magnetic field due to infinitely long wire. Now this long wire's derivation is not there in your syllabus. Definitely formula is there, but derivation is not there. So we'll also be just learning the formula only. See, if infinitely long wire is there, then magnetic field is equal to mu naught I by 2 pi a. How is the derivation done? Derivation is done through Biot-Savart's law only. All right, this derivation is done through Biot-Savart's law only. It's just that current element dl gets integrated. Fine. So don't worry about the derivation. It's not going to be asked. What is a semi-infinite wire? A semi-infinite wire is a wire which has one end proceeding towards infinity, but the second end is fixed. And the point which we are calculating, it is near the fixed end. This is near the fixed end. All right. So that is the semi-infinite wire. So it's just that, see, infinite is mu naught I by 2 pi. So for semi-infinite, it will be half. So it was mu naught I by 4 pi a. And see, this end is the finite end. Always have the point near the finite end. Okay. Yes, one thing. See, point lies near the one end. This I've discussed. Magnetic field is inversely proportional to the separation. This is important because graphs are asked from this also. Electrostatics and magnetostatics, there is a relation which we'll be doing in the next chapter, 5th chapter, we'll be doing that relation. There you will see everything is similar. Magnetic dipole will also be coming. Magnetic force, same thing, everything is going to come. So graphs also are important. Look at this question. This question will help you to remember. See, basically all the points I have written it here only, A point, B point, and C point. Now it's an important question from your wire perspective, because we have covered all the points in this. Infinite B, semi-infinite B, and axial also. So let's talk about A point. Forget everything, just focus. This is not present, this is not present. We just have A point. A point is separated by 2 meters from the wire. Here the current which is moving is 10 amperes upwards towards J cap, right? Y axis. Fine. And we don't need anything else to. So this is an infinite wire. It's mentioned near A point, and that's mentioning has been done through the question itself. I have not written it. It's from the question. So A point, magnetic field at the A point. See, this is mu naught I divided by 2 pi A. So class, mu naught is written as 4 pi into 10 to the power minus 7. Current is written as 10 amperes here in this question. This is written as like this only. I have told you, I think. U naught is equal to 4 pi into 10 to the power minus 7. Have this in mind. And then this is 2 pi and A. What is the separation? 2. So 2 pi, 2 cancelled. So 10 to the power minus 6. Now, this is incomplete without the direction. Current is going up, point is here. So inwards, right? That means negative z-axis minus k cap Tesla. This is the answer for the first part. Second, come to semi-infinite, which is, no, B point is here. Okay. Now, class, this is very interesting and this is very important too. You will be needing it a lot when you'll have combinations. You'll not get separate questions. Like when I was saying this is important, I mentioned also, it is important in terms of the wire type only. सिर्फ wire वाले में important है, like infinite wire वाले. This is not important as in for the whole perspective, because you will be getting mixed questions. You will be having infinite wire, then a circular loop, and then round it will go through a semicircle and a straight wire coming forward like this. So for mixed questions, this B point is important. Why? Class, can anyone tell me without even any calculations, anyone from you, according to you at B point, what should be the magnetic field? Anyone? And just a hint, use Biot-Savart's law only. Biot-Savart's law will only give you the conclusion for that. B point. B point is located where? Check with respect to the wire. Tell me what should be the magnetic field. Tell me the formula. Tell me the method. Tell me the value only. What should we put? Anything what you think should be the answer for B point. Check the angle of B point with the wire. That's the maximum I can say. Now you have to apply your brains. How are you going to manage the modifications which are going to come in your board exam? As it is, the questions aren't going to come. What is the angle that the B point is making with the wire?
90 degrees.
90 degree. This is the wire, this is B point. This angle is 90 degree. Aaya. B point is on the axis. You have done electric field on the axial line and equatorial line. You know the difference. When equatorial line is there, 90 degrees here, A point is at 90 degree. You can see here. How come B point you can see it is at 90 degree?
180.
180 degrees, 0 degree, these should have been the answer. Correct, Mariam? C class. Straight away, now remember this because this was your first time, so it's okay because you have not done this chapter with me right now. See, whenever the point is there along the axis, straight away write the magnetic field as 0. Because sine 0 degree or sine 180 degree is being formed. Straight away magnetic field will be 0. Just have this very clearly in your mind. Now I hope you will be remembering this also because I had asked you in the class. So remember this. This is important. Do not waste your time in your calculations because ultimate answer is 0. So magnetic field for this B part, this is straight away 0. We have the answer for the C part. C part is semi-infinite. यहाँ पे logic कुछ लिख लेना sin 0 degree in Biot-Savart's law when you put. This is mu naught I by 4 pi. So 4 pi into 10 to the power minus 7. Current is again 10. 4 pi. A is 2. This becomes 5. So this is 5 into 10 to the power minus 6. Now again, let's complete our answer. Same thing. Straight wire, C point here. Inwards. Negative Z axis. Minus K cap Tesla. Tell me all of you now. This entire portion of the wire is clear to all of you. At least give a thumbs up in the chat column, in your ID, or write yes, no, clear. Any doubts?
Clear, ma'am.
Others, only Yaya has to answer. Okay, Mariam, Zaina, Yaya, it's clear to them. Khadija, Rishita, any doubts? It's clear. Okay, write it. Any question, any query, please get it clarified. Write it. Done class, just text me done once P class, in this question, you have to calculate the magnetic field at this point P. So one straight wire is there, current I infinitely long, you can see from the diagram. Similarly, second wire, 2I current infinitely long, and see both have the separation A from the center where the calculation has to be done. So look here, when we are calculating the net magnetic field, this is equal to B1 vector plus B2 vector. So B1, this is equal to mu naught I by 2 pi A. Now, when you are calculating it, see, when you put your right hand along the side of upwards, basically upwards, you curl your fingers towards point P. So where is the thumb pointing? Thumb is pointing inwards. So this becomes minus K cap plus this is mu naught. Now the current is doubled 2I by 2 pi A. This is K cap. So what we can do, we can take mu naught I by 2 pi A K cap common. So we are left with minus 1 plus 2. So final answer is mu naught I by 2 pi A K cap. Fine. Complete this 2 class. Done?
Yes, ma'am. 1 minute.
Text me, done all of you once completed. Okay, class.